Hi, I'm Ezra and this is an episode of Ezra Talks. For today's topic, I'm going to discuss about the pulse code modulation. Pulse code modulation is used to digitally represent sampled analog signals. It is the standard form of digital audio in computers, CDs, digital telephony, and other audio applications. The process of pulse code modulation includes sampling, quantization, and coding. The first step in PCM is sampling. Sampling is the process of generating pulses of zero width and of amplitude equal to the instantaneous amplitude of the analog signal. Or simply sampling converts analog signal into discrete signal. Let's take this as an example. Assuming this is a segment of a voice call which is equivalent to 1 cycle or 1 second. The equidistant lines you are seeing are the samples. The ratio of samples present in a cycle is called sampling rate. So if there are 10 samples in a cycle, it means the sampling rate is 10 samples per second or 10 Hz. Since this is a voice call or a phone conversation, the ideal sampling rate is 8 kHz or 8,000 samples per second. For audio like CDs or MP3, the sampling rate is 44 kHz or 44,000 samples per second. And for the Blu-ray discs, the sampling rate is approximately 1 MHz or 1 million samples per second. In the process of sampling, it must find the sufficient number of samples in order to represent the original signal. The higher the sampling rate, the better the quality. The next step is quantization. Quantization is the process of dividing the maximum value of the analog signal into a fixed number of levels in order to convert the PAM into a binary code. Or simply quantization converts the discrete signal into a digital signal. The quantizing of an analog signal is done by discreting the signal with a number of quantization levels. Quantization is representing the sampled values of the amplitude by a finite set of levels, which means converting a continuous amplitude sample into a discrete time signal. This figure shows how an analog signal gets quantized. The blue line represents analog signal while the brown one represents the quantized signal. Both sampling and quantization results in the loss of information. The quality of a quantizer output depends upon the number of quantization level used. The discrete amplitudes of the quantized output are called representation levels, or reconstruction levels. The spacing between the two adjacent representation levels is called a quantum or step size. This figure shows the resultant quantized signal, which is the digital form for the given analog signal. This is also called staircase waveform. There are two types of quantization, the uniform quantization and the non-uniform quantization. The type of quantization in which the quantization levels are uniformly spaced is termed as uniform quantization, while the type of quantization in which the quantization levels are unequal and mostly the relation between them is logarithmic is termed as non-uniform quantization. In quantization, we have the so-called bit depth, the number of bits in every sample. The most common bit depth in analog to digital conversion is 8-bit, 16-bit, and 24-bit. The 8-bit depth is composed of 256 levels. The 16-bit depth is composed of 65,536 levels, while the 24-bit depth is composed of 16,777,216 levels. The last step in the process of pulse code modulation is coding. In this process, It will convert each sample to a specific binary number. So a 1-second voice call analog data will result to a long stream of zeros and ones. And that concludes our discussion of pulse code modulation. Thanks for tuning in, stay safe, and God bless.